Look at your tires. Right now, they're the only thing keeping you from a catastrophic slide, but the real magic is happening in the shadows behind your wheels. Most people think their car just bounces, but under that metal skin, there's a silent war between comfort and physics. It's the secret to knowing why a $20,000 hatchback feels like a vibrating tin can, while a luxury sedan feels like it's floating on a literal cloud. Today, I'm stripping away the jargon to show you exactly how your car talks to the road. 1. The universal. Standard, the strut assembly, MacPherson strut, meet the daily bread of the automotive world. Born in the late 1940s by Earl MacPherson at Ford, this setup is the king of efficiency. By merging the dampening unit and the coil into one vertical pillar, it saves massive amounts of engine bay real estate. It's the reason modern front-wheel drive cars have so much cabin room. Single combined unit saves space and reduces weight, ideal for compact and mid-size cars. Car like Toyota Corolla. Uses front MacPherson struts for a smooth city ride and affordable maintenance. Honda Civic. Strut setup contributes to its spacious interior, despite a compact footprint. But here's the trade-off. When you push it into a sharp bend, that pillar leans, causing the tire to lose its optimal flat contact with the asphalt. Perfect for the commute, but it wilts on a racetrack. 2. The geometry king, the twinna arm, double wishbone. If the MacPherson strut is a basic ladder, this is an Olympic fencer. Using two triangular arms that resemble bird wishbones, it keeps the tire perfectly vertical, regardless of how much the car leans. This is the holy grail for grip. Maintains near-perfect camber, tire angle, through the full range of suspension travel. Critical for high G cornering. Car like Honda S2000, AP1/AP2. Legendary for its razor-sharp front double wishbone, enabling 9,000 RPM cornering confidence. McLaren 7.2. OS uses a carbon fiber double wishbone at both ends, multi-million-dollar geometry choice. It gives the driver a direct handshake with the road, though it's expensive and bulky to fit into a normal car. 3. The master orchestrator, the multi-link. Imagine 5 different mechanical fingers all working in harmony to hold a single wheel. This is the elite choice for German luxury. It's a complex dance that allows the car to be bipolar. Razor sharp when you're driving fast, yet soft enough to soak up a pothole like it never happened. Independent control over toe, camber, and caster simultaneously, adaptable to both comfort and sport driving modes. Car like BMW 3 Series G20 2023. Front multi-link that separates lateral and longitudinal forces for legendary handling balance. Mercedes C-Class WW206. Rear 5-link for near-silent motorway cruising at high speed. The cost? A mountain of moving parts and bushings that will eventually make your mechanic very rich. 4. The Space Saver. The twisting beam. Torsion beam/twist beam. The most misunderstood member of the family. It's essentially a single metal bar connecting the rear wheels that's designed to flex. It's cheap, nearly indestructible, and leaves massive room for your trunk and fuel tank. The H, or U-shaped beam, flexes to act as its own anti-roll bar. Brilliant simplicity that eliminates multiple components. Car like Renault Clio Mark V. Rear twist beam keeps the load floor flat and maximizes boot space. For a city car, it's a stroke of engineering genius that keeps sticker prices low. 5. The heavy lifter, the Iron Bridge, solid/live axle. Pure, unadulterated strength, a solid metal beam locking both wheels together. It's the old guard. While it handles like a tractor on a twisty road, it's the only thing you want when you're hauling 3 tons through the mud or launching a 1,000 horsepower dragster. Wheel-to-wheel rigidity means zero geometry change under load. The axle wrap and articulation that off-roaders depend on. Car like Ford F-25 Super Duty 2023. Rear solid axle for towing 22,800 pounds without geometry flex. Land Rover Defender 90 Original. Coil-sprung solid axles front and rear defined its legendary go-anywhere capability. Dodge Challenger SRT Hellcat Dragspec. Rear solid axle for consistent, repeatable launch control at 707 plus horsepower. Unkillable engineering from a simpler era. 6. The Cloud Surfer, the pneumatic system, air suspension. Why use metal coils when you can ride on a cushion of atmosphere? By swapping springs for high-pressure rubber air bladders, your car can literally inhale to lift itself over rocks or exhale to hunker down for a high-speed run. variable ride height and spring rate at the press of a button, the only system that can be a true off-roader and a luxury cruiser. Car-like, Mercedes S-Class, W223, E-Active Body Control. Air suspension reads the road ahead with cameras and preemptively adjusts each corner. Range Rover, L460, 5 selectable terrain heights from -50mm road to +75mm extreme off-road. Tesla Model S Plaid, auto-lowering air suspension cuts drag and improves stability above 120 km per hour. It's the pinnacle of luxury, though a single tiny air leak can turn your dream ride into a sagging nightmare parked on its bump stops. 7. The Digital Wizard, Magnetic Ride Control, Magnetorheological/MRC. This is actual science fiction. By filling shock absorbers with a fluid infused with microscopic iron particles and using electromagnetic coils, the car can change its effective stiffness in under 1 millisecond, faster than the blink of an eye. The iron particles align to form rigid chains, stiff or disperse freely, soft, under electromagnetic control, reading road texture up to 1,000 times per second. Car-like, Ferrari SF90, Stradale MR. C working in tandem with active aerodynamics and adjust 10 times per wheel revolution at 200 km per hour. Cadillac CT5V, Blackwing, 3rd generation MR. C for American muscle that corners like a track car. Chevrolet Corvette Z06, C8, magnetic ride control. 4.0 responds in 1 millisecond to keep the flat plane V8's torque planted. Audi RS e-tron, G, T, MR, C in an EV platform, managing the instant torque of dual motors without passenger discomfort. It's the ultimate bridge between hardware and software. The hardware feels the physics, the software rewrites the response. Every car you've ever loved was a specific choice between these mechanical personalities. A Honda S, 2000, and a Ford Wrangler share 4 wheels and an engine, but they live in completely different universes because of what hides behind those wheels. So, tell me, are you building for the uncompromising grip of a track monster, or are you chasing the effortless glide of an executive cruiser? Drop your dream setup in the comments, and I'll see you in the next deep dive into the machines we drive.